Hello and welcome to Not a Buffalo, the show where we discuss the science and technology that will save the world. My name's Jack and welcome to 2021. This is Ben and I hope, I pray he's looking forward to this year more than he did the last one. Ben, how are you?
I'm very well. I would like to point out I was quite looking forward to 2020 until it happened. But no, I'm feeling hopeful. I'm feeling very optimistic about 2021. I think it's off to a good start. We've got some great stories to talk about. They give me a lot of hope for the future. And just in general, you know, we're kind of, for me, I'm used to lockdown now. I can deal with it. How are you, Jack?
I'm good. What I really enjoyed was when you said, I know lockdown, I can cope with it. You twitched just in the corner of your left eye.
I spend a lot of time in my own head at the moment, so who knows what I'm really thinking.
Yeah, but you have such a nice head.
Thank you, so do you.
Oh,
Your gigantic head.
Yeah.
To all the listeners out there, if you want to send us any presents, do not send hats, because hats do not fit Jack. His mighty cranium cannot be contained in any hat made by humankind.
I think if you added up all the hours you and me have spent looking for hats for me, specifically just headwear for me, like together in various shops on various continents, you would probably be able to produce a decently sized audiobook. It'd be a terrible audiobook because it would literally just be me going, oh no, this one doesn't fit either.
I'll always remember the first time I realised this, when you gave me your hat and you started by putting it on and it didn't fit you. But it was big enough that it could kind of balance on your head somewhat securely, but it didn't fit as it should have done. And then I put it on and it fell down over my eyes to my nose. Yeah.
And I do consider you to have like a larger than average head. I don't think you're a small-headed man.
I'm not. I don't think. Like I tend to have to, just judging on when I try on hats, I do tend to have to put them on slightly larger sizes. But yeah, nothing compared to you.
Yeah, it's brutal. It's brutal. So Ben, do you have any stories for us?
I do, and I thought for the first story of 2021, I was going to do a combination of two of my favourite things that I've mentioned on the podcast quite a lot. So this story involves both graphene and batteries. So this was a study done by the Technical University of Munich over in Germany, and they've basically been able to create a highly efficient supercapacitor. So I'm just going to give some background to what that is. So we're probably all familiar with batteries. You have the alkaline batteries that you're probably familiar with, that you've been putting in your Christmas lights or in the new toys that you got for Christmas, maybe now or maybe when you were a child. And then you have lithium-ion batteries, which are used to power things like laptops and phones and stuff like that. A supercapacitor is actually something that's very similar, does the same job essentially. So its job is to store energy and then release it on request. But the difference is that supercapacitors are able to store a lot of energy quite quickly and then put it out much faster instead. And they're being used a lot more in laptops and batteries. The example they give here of when a supercapacitor is quite useful is when a train is braking as it enters the station. The supercapacitors can store that energy and then provide it again when the train needs a lot of energy to very quickly leave when it's starting off onto the next leg of the journey. But a big problem, historical problem that's been with supercapacitors, I say historical, they're not that old a technology, but one of the problems that people have been having with them is that they don't have very good energy density, which means you can't store a lot of energy. Compared to a battery, you'd need a much bigger supercapacitor to store the same amount of energy. You couldn't pack as much energy into the same size. And so a team with Roland Fischer, who is Professor of Inorganic and Metal Organic Chemistry at the Technical University Munich, worked on with an international team actually, and that's something I want to get into a little bit later in this story. But he developed a new sustainable graphene hybrid material for supercapacitors, and they've used this for the positive electrode of the supercapacitor. So similar to batteries where they have a positive and a negative electrode, so the bumpy end and the flat end. To keep it simple, this one is the same. So the positive end is a graphene hybrid, and then they combine it with a negative electrode, which is titanium and carbon. And this manages to achieve a much higher energy density. So it's equivalent to a normal battery, essentially, a nickel metal hydride battery, which is quite a common type of battery that you can get. But this is much better than other supercapacitors have been. And the benefit of this is you get a battery that can charge up super fast, that can discharge very quickly, and can hold a lot more energy equivalent to batteries. And these are one of the things I love about this article is that they say that they basically looked into nature and at all the kind of complex, optimized hybrid materials that exist in nature. So, for example, bones and teeth, which are hybrids of lots of different elements and components that come together to be the right amount of hardness and elastic and things like that. So it's quite an abstract idea, but they've managed to create this now, this battery. And one of the other key parts of it is that it has a nanostructured metal organic framework called a MOF, which I just quite like that. That's an acronym.
That's quite cool. What's the advantage to it being nanostructured? Is this some kind of strength thing that it requires?
So the benefit of it is that you can control the pore sizes, which I think helps with the charging and the discharging, but it also still has a high electrical conductivity as well. So you need the kind of the graphene, which is highly conductive, and then you need these microporous MOFs as well in order to make this battery. And another good thing that they highlight, and because it's graphene as well, that's really useful because a large surface area is really important for good supercapacitors because it allows them to collect a large number of charge carriers. So electrons, for example, in that. Yeah, I mean, it was quite an impressive feat, and it's one of those things. It's also the further benefit of this. It's just a whole list of benefits here. Is it's also much more stable. So a classic lithium accumulator or a lithium battery has around a life of 5,000 cycles, so you can charge it up and discharge about 5,000 times before it becomes useless or less effective. Whereas this one seems to be able to retain over 90% capacity even after 10,000 cycles, so it lasts twice as long as many other batteries. It's very new. This story is from the 4th of January of this year. One of my favorite things that this could revolutionize. You could have a phone, maybe in the near future you'll have a phone that only needs to be charged up once a week, or it can charge up fully in 10 minutes. Supercapacitors are the technology that could make that happen.
Yeah. It reminds me of the Ambri battery company. I don't know exactly what's happening with them at the moment. I've not been following them, but they've developed a liquid metal battery, which is quite cool because they've developed it to use very abundant materials. Lithium-ion batteries use rare earth elements, and lithium is not cheap and is not that cheap, and is not that abundant.
And it's found in difficult places as well. Like it's often, companies often get it by exploiting poorer countries in Africa and Asia, I believe. So not using lithium, if we can, is a good thing.
Yeah, but that's the trouble, is sort of the whole battery production line is sort of orientated around this particular type. In the same way it was all orientated around zinc batteries in the 70s. That was, and everyone was like, oh, you're going to make a lithium ion battery? That's crazy. You can't do that. So it's going to be quite interesting seeing whichever of the new battery technologies does get adopted, how that gets adopted, because getting that into the infrastructure and getting it adopted by large-scale manufacturers is going to be kind of a challenge. Did they mention anything in this about like the use of it in industry or anything like that?
Not in this article, no. They're just really talking about how it works, what they've discovered, and they kind of leave it at the fact that this is a supercapacitor and supercapacitors are great and have lots of uses.
Oh, they are. They're amazing.
Yeah, but at this stage, they're not talking about, apart from mentioning at the top what you might use supercapacitors for, they don't go into the detail of how this could be commercialized or scaled up to be used on a large scale as well. So, and I agree with you. It is really interesting. It will be interesting to see, and I know, as I mentioned at the start of the story, I've talked about batteries quite a lot because they are going to be so important for the future of being able to store energy from solar panels and from wind energy, and for giving cars, a good supercapacitor probably means that you can charge up an electric car very quickly, and if you can improve the energy density like here, then you can make it last long enough that it will drive for a lot longer on a single charge than a petrol tank would in a traditional car, and that's great for the environment and for noise pollution and for everything going forward. So it's good that we have a lot of options, and I'm glad we get to talk about batteries a lot because I think they are going to be such a crucial technology for the future. But you either want to win out and be scaled up quickly, or you want that even if there are lots of options, it's not going to affect us from a consumer standpoint. We can still just plug, and the plugs will be standard at least, and we can charge them up and use them no matter what they're made of. Yeah.
I mean, actually, you mentioned renewables there, right? And if you want an electrical grid, so like a national electrical grid or an international one for that matter, for providing this kind of electricity that comes out of a plug socket, you actually need batteries to be a part of that. Most national grids require that they produce almost exactly as much electricity as is being used at any one time. They don't really have storage capacity.
Yeah.
It's a kind of balancing act whereby they sort of just shovel more coal into the furnace. I'm using a crude analogy, but they sort of dial up the amount of electricity being chucked into the grid to match the amount of demand, which is why something as simple as like a depressing episode of EastEnders can cause a blackout when everybody in London puts the kettle on after EastEnders. And the sort of issue you have with renewables, the primary one, is that most of them don't consistently output electricity. Wind, it depends on the wind. Solar, it depends on the sun being up. The hydrothermal, yeah, sure, but good luck powering a whole country on it unless you're Iceland. So it really is a case of having some kind of battery that can be cheaply produced and can store lots of energy. And stuff like supercapacitors is so important, because without a decent supercapacitor and a decent battery, there is no green revolution on a national grid scale. It cannot happen.
Exactly. And it is still such nascent technology. There was such a big deal when Elon Musk's company, I can't remember the name of it now, Solar something, built that battery.
Solar City.
They were the ones who built the battery farm, or the big battery storage in, I believe it was in Australia, to help with their storage so that they could actually start using. Because as you say, at the moment, it is a case of, right, it's coming up to 6 o'clock, everyone's going to be heading home and, turning the oven on and turning the kettle on from work back in the days when that happened. But we need to ramp up, throw more coal in and put the green bars more into the nuclear reactor, or however that works. But that was a recent thing, and it is difficult to build the size at the moment. Can you imagine having, the size of a double A? You can't scale that up you can't just put together 1 million double A's. While we're on the topic of international, I really like how this article finishes off, because it feels like it's a little bit of a dig at what's been going on in the world over the last while. The lead researcher, Fisher, really emphasises how important the unfettered international cooperation has been. So the guy who actually built the team originally is a guy called Jairamulu Kolibuyina, who is a guest scientist from India, who was invited over to Germany. And then they also tapped into battery expertise from Barcelona and graphene derivate experts from the Czech Republic. And they also had partners from the USA and Australia. And I just really like that they finish off by saying this study was done through a collaboration from people from 4 different continents, and that's so important for science going forward. And I just really like that they added that in, and that he's really stressed in this article, we needed this to be an international effort, and it's really cool because of that.
Yeah. Some things are more important than national boundaries, aren't they?
Exactly, like clean, safe energy that's going to keep us all with our cups of tea and cups of coffee and whatever other drink they drink around the world, because we're not in a predominantly coffee or tea drinking country, or from predominantly... No, we said we're from the UK originally.
I think you'd be hard pressed to find a country which is neither coffee nor tea predominantly drinking.
Bet there is.
As a caffeine stimulant. I very much doubt there's a Red Bull specific country.
No, I can just imagine there's a country where... I guess no, now that I think about it, they're almost everything I'm trying to think of is basically a type of tea. Like, even I was thinking something like kombucha is basically a kind of tea, and
Yep.
Okay.
Yeah, once you put leaves in water, it's tea.
So that's my first story. And I know we've mentioned graphene and batteries a lot on the podcast, but it's always good to see how these kind of technologies are being used in a new and interesting way, and how it's all just kind of, it feels like it's the start of the future. It's the same way people, when they were talking about the motor car first coming in, for example, feels a little bit like that. Like these materials that are they're on the periphery now, but you keep hearing more and more about them, and they keep being discovered that they can do all these amazing things. And what's your first story, Jack?
My first story doesn't really segue particularly well from this, but my first story is sort of green related, and it's to do with using artificial intelligence to find hidden roads in the Amazon ecosystems, because those roads are statistically a threat to the Amazon rainforest, because a lot of these roads are illegal to start with, and nearly 95% of all deforestation in the Brazilian Amazon happens less than 6 kilometers from a road, or a kilometer from a river, and you can sort of track that. And so what they've been doing is they've been using satellite images, and they have been chucking these at an artificial intelligence which is much better at picking out roads than a human being is, and it's mapping them out, and then they're sending people to close off the roads. And this is part of an effort to save the rainforest, which is something that I can't believe we're still having a discussion about in 2021, when we've been talking about needing to save the rainforest for the last half century. So yeah, that's my first story, is about trying to avoid the apocalypse again.
It does boggle the mind that they're still, because presumably these are like dirt roads that are very hastily made by logging companies that are trying to get deeper into the forest. Is that right?
Exactly, it's exactly that. Yeah, it's primarily if you just stop the illegal logging, you'd be saving a huge amount of the Earth's resources. Like it's crazy. But yeah, that's exactly what this is for. It's to try and avoid that.
That's incredibly impressive. As I said, it's just a dirt road kind of going through the rainforest. The fact that you can train an AI to pick it out and they can go and close it is fantastic. I wonder though, and it's probably not included in the story, but it almost feels like that's not the right measure. Like it'd almost be better to stop people buying the logging trucks or the dump trucks, or is it, I don't know if it goes into any detail in the article, but is it just, a lot of people buy them legitimately for legitimate businesses and you can't, and then they sneak off and do some illegal logging?
Yeah, that's part of the issue. The other issue is also there are still economic incentives. Like good quality wood is expensive. If, say, you happen to be quite poor and you live in somewhere that's like where there aren't many economic opportunities, like next door to the rainforest, because a lot of that area is very poor.
Very good point.
If you can turn a quick buck by doing a little bit of logging on the side, wouldn't you? Like,
yeah.
If you had nothing else, you probably are gonna, and this is the issue. It's like the economic incentives are sort of there to deforest, and while they're there, people are going to try to take advantage of them because that's how society operates.
I think that's a really good point, and it's something that we often overlook when we talk about these things. You say they're terrible people for logging the rainforest, as I did earlier in this segment, and actually you say, well, what is their alternative? In some parts near the rainforest, the alternative is probably drug running for the same reasons, or it is trying to be a subsistence farmer, and you can see why people do these things because they have to a lot of the time, or because it is the best, not even because they have to, but because it's the best option. Certainly if I was given an opportunity between steal money or have to climb Everest every single day to get, and then we'll pay you slightly less money to go and climb Everest every day, or you can steal the money, I'd probably resort to stealing. And I like to think of myself as a good person, but
yeah. And even if you only steal like 1 out of 10 days because you feel like 9 days climbing Everest has just been enough.
Yeah.
You're like, okay, I'll just steal 1 of the days out of 10. It's still an issue. That's because everybody's doing it.
And to do a bit more of a, perhaps a more realistic analogy is if you are in one of these communities and you have a new child comes along, or it's your daughter's wedding or your son's wedding, or you want to send your son to university or your daughter to university so that they have the opportunity that you don't have at the moment. You need some extra cash to do that. I don't know what, I don't want to be an apologist for this, but I think we need to point out that there's the reason this is happening isn't because people are evil loggers who don't care about the environment a lot of the time.
Yeah. It's not really about being an apologist, is it? It's about identifying this is one of the things which makes it a difficult thing to attack as a problem, right? So, and this is one of those interesting things about climate change is very quickly when you go, okay, save the rainforest, it becomes not just a discussion about being able to track where the deforestation is going and to actively combat it by breaking down the infrastructure that's allowing that. But then you also have to look at the economic incentives that is causing that infrastructure to be created, the infrastructure in this case being illegal roads into the Amazon for logging. And then very quickly, a climate change discussion becomes both a very technical discussion about AI and also an economic discussion. And that's one of the challenging things about climate change is it requires combined solutions in so many areas. It's quite clear, in a sense, what a lot of those areas are. It's just a matter of doing.
Yeah, and I think it's why there's so many movements now that don't talk about climate action, they talk about climate justice, because the two often go so closely hand in hand. If we want to save the world, we also need to really invest in underinvested communities and in poorer communities that are bearing the brunt of it in so many ways, both economic and because they are the ones that get the pollution dumped on them and the landfills put near them and their homes destroyed and etc. But it's a positive development. The fact that they can map this out and spot it and do something more to help save the rainforest, I think, is fantastic.
I didn't expect us to go so deep on the green there, but I'm happy with it. I should also mention the guy's name who was involved in this.
Yes.
Who is called Carlos Souza, and he's based at a Brazilian not-for-profit organisation called Amazon, like Amazon but with an I, which is quite a cool name actually.
That is, and very glad to hear they're doing this work. The Amazon is such an incredible living thing. It's it is a single living thing. All the fauna and the flora all connect together to form an incredible living thing.
Biome is the word.
Exactly. But if we say a living thing, that segue is slightly better.
Oh, sorry. I didn't realise we were in a segue. I thought we were in a technical discussion about biomes.
That's how good a segue it is.
Things. Tell me about things, Ben.
Engineers at MIT and Imperial College London have developed a new way to generate tough functional materials using bacteria and yeast. And it's very similar to a kombucha mother. So for a little bit of background,
what is a kombucha mother?
So kombucha is a cold fermented tea drink. It's become very popular in lots of places around the world. It's very good for your health. The fermentation process, without actually adding alcohol, is very good for your gut health and for the microbiome in your gut. So a very popular drink. But to make a fermented drink, it's the same way as when you make a fermented bread, like sourdough bread. So you have a starter dough that you take the bit from, and then you feed that with flour, and you create the bread from that. So it's kind of like the mother is kind of like the source of the yeast and the bacteria that you use to do the fermentation process and things. Same way to how kombucha is made. So you will have kombucha companies that have their mother thing, which is in fact Guinness in Ireland has a similar thing. They have the original yeast strain that was used to make Guinness, and they keep it under lock and key. It is the most valuable asset in the company, and they talk about this if you do the tour, which I've done a couple of times in the past. But yeah, and it's because if it didn't have that, then Guinness wouldn't taste quite the same. And so you keep this mother, this source going, and you always take it from there so that your kombucha recipe can be the same. And they've essentially created a new mother, except they've done some really incredible things with it. So they call this mixture a SCOBY, which stands for symbiotic culture of bacteria and yeast, and they were able to produce cellulose, which is essentially organic material. Yeah, exactly. Embedded with enzymes that can perform a wide variety of functions. So one thing that they could do is they could get this to sense environmental pollutants. So essentially you can put this material over something, and then it will react if there's a particular type of environmental pollutant present, and then you can obviously deal with it. But it can also do things like become a water purifier, or even create smart packaging that can detect damage. So you could wrap up a bit of glass, and this could detect, there's some damage here, this needs to be dealt with. And the really cool thing about it, so there's a guy, Timothy Liu, who's an associate professor of electrical engineering and computer science and of biological engineering at MIT, said what they envision for this is you can buy your own mother mixture and then grow it at home to make various different smart materials. So you could start making your own water purifiers at home, like something, you create it, you have a standard template, and you could put it into your water jug, like a standard water jug, and then when it runs out, you throw it away and you grow a new one instead.
And it's organic material, so it will biodegrade, presumably.
Exactly.
Wow. That's a fantastic breakthrough.
Yeah.
And so, because it doesn't sound like this came out of nowhere. This sounds like something that's like been developed over time. So I'm wondering what were some of like the antecedents to this?
Yeah, so Timothy Liu started out in his lab. He developed a way to use E. coli, which is a well-known bacteria that often makes you ill. But they used it to generate biofilms, so like a thin layer of, very thin layer of organic material, or biological material. And then they'd embed this with materials such as gold nanowires, which then you can use in a variety of applications, like in conduction, for example, in electrical devices. And what they wanted to do, they found that was one thing that they got, and they got pretty good at, but they wanted to be able to make it much larger quantity. And they realized that actually if we create a micro population in the similar way to someone creates a kombucha mother or a sourdough mother, I guess is another example, you can create essentially a fermentation factory, and then you can go from there. Essentially they've actually got a couple of Latin names which I might try and read out.
So
they say here: Most of the wild yeast strains that are used in kombucha are quite difficult to genetically modify, so they used a specific laboratory yeast called Saccharomyces cerevisiae, and they combined that with a type of bacteria called Comagatiibacter raticus, which their collaborators at Imperial College London had previously isolated from a kombucha mother. And this species can produce a very large quantity of cellulose, which is then you can turn into these sort of materials like the filter and everything. And they found because it's a laboratory strain of yeast, they could enter it. I still said that wrong, didn't I?
Also, Saccharomyces is a Greek word.
That's the name of the... so not Latin. Okay.
Yeah.
My bad. We'll leave
it's
in,
okay.
We'll leave in your correction. No, I think we should. But yeah, the reason
I think we should, but I think it's concerning that I still remember. Like,
looking at it now, that makes more sense. I think that it makes more sense looking at it like, oh yeah, that is
I don't know
a Greek
about
word.
the other one you mentioned. That might be Latin, but Saccharomyces for sure is Greek, because sacchara is the Greek for sugar.
Oh, that makes sense, because you have the saccharin sweet as a descriptor, and I think that's the name of a sweetener as well, isn't it? Saccharin or something like that.
Yeah.
Because the researchers use this laboratory strain of yeast, they can engineer the cells to do any of the things that this lab yeast can do, which they've already kind of specifically created to do a wide number of things. So it can glow in the dark, it can sense pollutants, and it can be programmed to break down the pollutants after detecting them as well. So it's just, I was looking at it and it was really cool. And to demonstrate the potential of what they can do with it, one of the things they did, which was really cool, is they used a strain of yeast that produces a glowing protein called luciferase when exposed to blue light.
Oh, that's nice.
And yeah, like I love the fact that they're thinking anyone can do this in their home or kitchen if we can just give out the templates. I do use water purifiers, and I'd love to stop buying plastic ones and have an alternative solution to that. So a biodegradable water filter that you can grow yourself whenever you need it sounds brilliant.
And just to continue our segment, is it Latin or is it Greek? Lucifera is definitely a Latin word, because Lucifer means light bringer.
Yes.
Maybe this should be a new segment for the show. Is it Latin or is it Greek? And then we both have to guess. You know, we both bring a Latin or Greek word, and we go,
and then look at the root of it. I like that idea. That's quite cool. That's quite a good idea.
I mean, I feel like it's strong enough that it could hold up a podcast on its own, but that only I would listen to.
I just wanted to add in as well. So the two lead authors of this are MIT graduate student Zhu Chietang and Cambridge University postdoc Charlie Gilbert, and then the senior authors of the paper are Timothy Liu, as I mentioned earlier, and Tom Ellis, who is a professor of bioengineering at Imperial College London.
Cool.
I think that'd be a fantastic job, professor of bioengineering. I just imagine you come home and I've got this really amazing new water filter, try it out. So like, I grew that in the lab today, or here, try this dress I bought for you. Oh, I grew that in the lab today.
Yeah, so birthdays become substantially cheaper as a professor of bioengineering, don't they?
Cheaper for him, maybe, if he could access it for free, but I imagine there's quite substantial sums of research money gone into this.
Yeah, true.
And kombucha itself is not cheap either. It's still one of those kind of trendy health drinks that means it's still like $3 a bottle, or euros a bottle, or pounds a bottle, or renminbi a bottle. Or yen
the real
bottle.
question is it expensive because it's difficult to produce, or is it expensive because hipsters like it too much? I suspect it's the latter.
I think it is the latter. So yeah, look forward to the future where you can grow not just sourdough and kombucha at home, but also water filters and smart packaging. And that's the end of that story.
I think that's such a cool idea. The idea of do it yourself, smart materials, grow it yourself, smart materials. That's such a great idea.
I'm so glad I was looking through my newsfeed today for some extra stories, because I only had a few ready, and I'm so glad I came across that one today. It was only released today on the 11th of January, and yeah, just a really cool story.
My next story is not about yeast, which is how I'm going to segue to everything in the series this year.
It's just not about what I was talking about.
Exactly. Yeah, so this next one is not about yeast. It's about identical twins not really being identical.
Isn't it kind of in the name? They are identical.
Yeah, you'd think it, wouldn't you?
You're about to ruin a lot of films, including The Parent Trap, Jack.
I have never seen The Parent Trap. In fact, I don't know if I've ever seen a film which had identical twins as a central point of the story. Can you name some more?
There's the television series Orphan Black, and there's a film that my partner has loved watching called The Princess Switch, But both of those aren't actually about identical twins. They're just about they happen to run into identical strangers. Like strangers who they've no idea about and look exactly like them. Which seems much more far-fetched than identical twin plot. But I'm sure there are other films that identical twins are... Oh! The Prestige. There you go.
Oh, yeah. Yeah, I have seen that. And that's a good film.
It's a very good film. And twins are... Oh, spoilers. Sorry. we might have to cut all this.
Also, it has David Bowie playing the only role that he was ever destined to play after Labyrinth, which is Nikola Tesla. I've seen quite a lot of on-screen representations of Nikola Tesla, and David Bowie as Nikola Tesla in Prestige is the Tesla. Like, that's my Tesla right there.
Remove all of that and just have David Bowie as my Nikola Tesla in the middle, and then move on.
I think we might have found our episode name in that.
Yes. Oh, yes, definitely.
But moving back to the identical twins that this story is about, a study was published recently. Differences between germline genomes of monozygotic twins.
And monozygotic means that the twins came from a single egg, is that correct?
Yes, it does. See, you do know your Greek.
I remember my biology lessons in secondary school. More than my Greek, I think. It's been a long time since I was in ancient Greek, but secondary school was only between 15 and 45 years ago.
I feel like you probably could be an ancient Greek. You have the vibe.
I think especially now with the shaved head and the beard, I could definitely pass.
That's exactly what I was thinking. I was just like...
I'm a bit pale, though.
Yeah, but I mean, you'd soon tan up in the Greek sun, right?
I don't know. Where I'm from, we don't tend to tan. We just tend to burn and then shed. Is Ben a lizard person? The latest conspiracy on Not a Buffalo.
I feel like, for sure, you could get away with being a lizard person, Ben.
I like to think none of our audience are prejudiced. You know, as long as I'm a decent human being who entertains them, you know, lizard or not.
Lizard or fish, who cares, right?
Anything else we're against, but lizard or fish. You're really leaving a big job for yourself doing the first edit.
I know. I mean, I'm anticipating that most of this will be cut. Like...
I've now created a folder that says 021 Bowie is my Tesla, so we have to leave that bit in.
Bowie is my Tesla. So this study that has been produced by a lot of authors, so I'm just going to say the lead author, who is Hakon Johnson. I'm sorry, Hakon, if I'm mispronouncing your name. But yeah, this was a study that found that about 5.2 of the early mutations are different between the two of them, which means that early on in their development, you get a few changes. So they're not identical. It's a kind of really, really pedantic way of going, like, we thought, because we did think that monozygotic twins, when they were, because they split from the same egg, which was fertilized by a single sperm, would be absolutely identical, and it turns out that they're not, which is quite fun, you know? And this is also, because this is early developmental mutations, it probably is excluding the epigenetic element, you know, because like you could imagine that one of the twins grows up in Saudi Arabia and the other grows up in Iceland. They'd be exposed to different environmental stimuli, which might mean that their genes are realized in different ways. That's what we call epigenetics, is the sort of emerging development of genetics as it interacts with the environment.
Like the skin color, like if you are in Iceland, you're likely to be very used to the cold and be able to handle the cold but have quite pale skin and have a bit of a lack of vitamin D, whereas if you're in Saudi Arabia, this isn't an epigenetic, but you're likely to have paler skin and more tan skin if you're in Saudi Arabia. Although actually you'd probably spend a lot of your time in Saudi Arabia inside, so maybe you'd still have pale skin. It'd be quite hot to go outside in the sun uncovered.
Yeah, but to be sure, you'd develop a better tolerance for heat in Saudi Arabia than, say, Iceland.
Yes. I should have left it there. Yeah.
I thought that was actually a really good analogy of explaining epigenetics in a very straightforward way. Again, it is one study, and typically this sort of stuff, it takes quite a lot to shift the consensus, but it's a pretty robust study. It's got quite a lot of authors on it, so a lot of research has gone into this.
Did they just look at one set of twins, or is this multiple?
Oh, it's a lot. It's a lot of pairs of them. And the other thing is, it's been published in Nature, which is why I'm able to read it, because Nature's articles are available. Well, this particular Nature article is available for free. And that's a big deal. If something gets published in Nature, it usually means that it's groundbreaking, which is probably what makes it more impressive that Nature is a monthly journal.
So it sounds like this story is a relief to twins all around the world who can say, I am different from my sibling. You can't just treat us as the same person and buy us the same clothes all the time. I know a lot of studies use identical twins because they're useful to have someone who's basically identical. For example, when the astronaut, whose name escapes me, Mark Kelly, went into space, and they kept his brother on Earth. They could compare the two bodies and see how one being in space has been affected, which is very cool. But it sounds like it's such a minor difference, it probably wouldn't have ramifications like that for studies like that.
Those studies probably won't entirely fall apart because, as I mentioned before, there will be epigenetic differences between twins for studies like that. So Mark and his brother will have had some differences between them anyway, even though they were identical twins. But nonetheless, it'll be something that needs to be taken into account when designing further studies. And it's also something that, maybe in retrospect, at some point someone will go back over the old literature and be like, oh, I see that this relies on these mutations being the same, or these things that rely on these mutations being the same. It could well have effects like that. Still kind of it just sort of caught my eye because I was like, this is a little bit quirkier than a lot of the science I've read this month, which is, surprise surprise, mostly been biomedical. But yeah,
it's a cool story though. Unlocks even more kind of knowledge we have about the human being, how they're formed, how they're created. And it's
the thing that they mention in the article is that classically, if you took two twins and you separated them and one of them develops, say, autism, for example, and the other one doesn't, then the interpretation was always that you blame the environment. But of course, with this study now, that's an extraordinarily dangerous conclusion. Yeah. So you're right, there are huge impacts on both previous studies and future studies, because it isn't a case of you can just go, yeah, it's epigenetic. It must be epigenetic, this thing you've developed, and you could say that you could look at the same sort of stuff if one develops depression and the other one doesn't. You go, oh, well, you must be depressed because you live in Sweden.
A very cool story, and I think we're going to leave it there. I quite enjoyed doing a bit of a deeper dive into 2 stories rather than covering 3, and we still managed to fill up. I'm impressed actually. We've still managed to fill up the time. And now it's time for host knowledge, Hollage.
So this is the section where I roll a dice. The dice tells me a word. I take a card that corresponds to that word, and I read it out to Ben, and Ben answers, and then I answer. The game we're playing is called the Empathy Game, and it's available wherever you get your games. So without further ado, let's roll that dice.
They're not a sponsor, but we just like to spread more empathy in the world.
And the dice says who is, and the question on the card says, what's your favourite word?
Oh, God. That's a tough one. A lot of words are popping into my head now, and I like saying them, but none of them are really that pleasant. Facetious and despondent both popped into my head, and I don't know why, but I think I like the way they sound. I like the way they roll around my mouth. I was also going to say something kind of dull, like cake or chocolate. My favourite words because of what they entail.
I quite like the word nearest when it's applied to food. Nearest food is favourite food. It's a tough one, isn't it, when you're actually asked to pick just one?
Yeah.
It's got the issue of being a superlative, which is a word that I think is okay, meaning best, worst, favourite, least favourite.
Yeah. Favourite word. Oh, I need a lot longer to think about this. I don't know. We're just going to leave silence here for like 3 hours and then come back when I've had to think about it. You know what? I really like the word marvellous. I like saying the word marvellous in response to things. I think it sounds good. I think it entails a lot of great things, I think. More so than like brilliant or fantastic. I just think marvellous just sounds, I don't know. I really like it as an adjective when something good has happened, or when I hear some good news. So yeah, I'm going to go with marvellous as my favourite word. I'm sure I could think of lots and lots of different words that I like for lots of different reasons, but marvellous is the one that springs to mind that I'm actually kind of like, yeah, you know what? I really like that as a word in and of itself, and the way it sounds and the way the way I say it as well. So yeah, I'm going to go with marvellous.
You do use that word a lot. Like, I hear you say marvellous quite... In fact, you text marvellous quite a lot.
I do like... It's a great response as well. Like, rather than the thumbs up, I like giving people a marvellous. Because, if I care about them, I just want to go for that little extra effort. If I send you a thumbs up, I still care about you. But, I really care if I've said marvellous.
Yeah. You almost... I mean, I think you've sent me maybe 2 thumbs up in our whole relationship.
I don't know if you have the same reason that I do. but I tend to avoid emojis unless I really feel I need them to kind of unless I think my sentence could be misconstrued and I want to put an emoji in.
Yeah.
I quite like the sort of the one that's kind of with the like smiling but with a little bead of sweat, kind of like kind of serious, not really serious.
Awkward emoji.
Yeah, the awkward emoji.
See, I'm kind of with you. I don't use emojis except for like when I worry that my meaning could be misconstrued, and so I sort of like go smiley face at the end of something if I think it's a bit serious. But most of the time I don't use them, and I think that's just because that's when I grew up they weren't really a thing. So I sort of learned to text without them. But there are a few that I really there are a few that I like the sound of the word, even though I don't like care for the thing it describes. Like still aside is a good example of that.
Okay.
I also kind of like the word exhibitors is kind of cool. They, I suppose, were like sentinels is what it would translate to. But they were part of the Imperial Guard in the Byzantine Empire under Leo the First, I think. Yeah, I think they were under Leo the First because they were like a special unit that was put together in the 5th century AD.
Okay, cool.
It was like second half of the 5th century. I can't give an exact date because I'm sort of pulling all this out of my head. But I quite like the word exhibitors because it sounds like what it is. It sounds like an elite unit of something, and it also sounds slightly archaic and old worldly, like something you'd have in Lord of the Rings.
Yeah, I quite like the word exuberant, which is what that made me think of.
Yeah.
It's a good word.
I wonder if there's any connection between those, because I actually don't know the origin of exhibitors. I just know the word. I'm not really a person who has, like, favourite words, if you see what I mean, because I think a lot, like, language is for communication. It's not for, like, putting in a case and decorating.
Yeah, no, I get what you mean.
But yeah, they're not things for display. They're things for use. Words are to be used.
I agree. Words most certainly to be used. That's a lot of good words, I think. Listeners, write in. Tell us what your favourite word is. We'd love to know. If any of you have very strong feelings about favourite words, I'd also love to know. Thank you very much for listening to the show. Please subscribe to never miss an episode and rate and review us wherever you have a power to do so. If you'd like to get in touch, we are at Not a Buffalo Pod on Twitter and Instagram, Not a Buffalo Podcast on Facebook, and you can contact us through our website, notabuffalo.wordpress.com. Happy 2021 and goodbye.
Bye-bye.